Right, so already, as I already mentioned, you're going to have to write these on the back of your notes because I don't think they're typed in there yet. And if they're typed in there, well, then you're just lucky. So we know how to take a common log on a calculator. We know how to take a natural log on a calculator. So let's find out, how do you take it if the log is a base of something else? Can everybody read A and B there? Can you read the bases? They're kind of small. You see them? Yeah, I can supersize them a little bit. Or not. There we go. They're a little slow today. Am I just missing it, or what's the deal? Apparently. Oh well. Need to orientate them. I'll just guess right there. There we go. They're a little bit bigger for you. All right. Oops. So first we're going to make an educated guess as to what this answer would be, and then we're going to use the calculator to actually figure it out. Because do you see a log base 3 button on your calculator? I see a log base 10 and I see a log base E. Right? There's no log base 3 button on, and there's no log base 2 button for the other one. So what would we expect this answer to be? Again, that means you have to understand what question's really being asked. And what question's really being asked is 3 to what power would give me 30, right? If we write it in exponential form, that's really what's being asked. And we should be able to get close to what that number is. For example, do you think the number is around 1? I think 1, 1.5, something like that. Is that a good guess? No, because 3 to the first is just 3, right? So how about something around 2? Does 2 seem like, notice these numbers are just right there, right? Does 2 seem to be a good guess? Well, no, because 3 squared is 9. Oh, so 2, probably not a very good guess. How about 3? 3 to the third is 27. Well, we're getting pretty close then, aren't we? So do you think it should be, when 3 to the fourth is what, 81? So do you agree that this problem right here would kind of fit in between those two, correct? But it is definitely going to be closer to which one, 3 or 4? A lot closer to 3, right? So our guess is somewhere between 3 and 4, and you can go ahead and make your educated guess right now. I would say anything under 3.5 is a very good guess, but I'd say 3.1, 3.2 are some of your better guesses. Okay? If you're going to just, when you guess, going to the tenths is probably sufficient. You don't have to just keep guessing, because let's face it, after the tenths, they're just random numbers anyways, when you guess them. So now, how are we going to do this on a calculator? That's the tricky part. Okay? As you're going to learn in the next section, you're going to see where this comes from and why it works. But on a calculator, what you can simply do, if it's a different log base, this is log base 3, you can take the common log of that number there. Notice it's a common log now. I've changed the base, right? And you divide by the common log of your original base. My original base was 3, and so we'll put that right there. Okay? And that will give you the answer. That has basically turned it to log base 3 for you. Okay? So we're going to take the common log of 30 divided by the common log of 3. Does everybody see where the numbers came from? Right? Okay. Now some people look at this and say, oh, it's 30 divided by 3. It must be 10. Well, no, because 3 to the 10th. That makes no sense at all. Okay, everybody ready to go to the calculator? Let's give it a try. So common log is the one I'm choosing, right? So it's that one, right? That's base 10 of what we say 30. And I believe all calculators that I see people have, do they give you the parenthesis, the logarithm? Yep. So now if I hit divide right now, I'm taking the log of everything I type in that parentheses. Do I want to take a log of everything I typed in that parentheses? No, I want to close that parenthesis off and say just take the log of 30. Okay? Find out what that number is. And then we're going to divide, okay, by log of 3. Now, what did we say this was going to be? Somewhere around a little over 3, right? So if we get something else, we should be a little bit surprised. Okay. Now, is it a little over 3 just because the base is 3? No, it's because of the number we're trying to get to as well, right? Yeah, what do we get? Oh, well, there we go. So there you go. 3.1 would have been an excellent guess. Now, I believe the directions say to round to the 10,000ths place when necessary. Well, is it necessary for this one? Well, yes, it keeps going, right? And so where is the 10,000ths place? Somebody, I think, said 4, right? Because this is tenths, hundredths, thousandths, 10,000ths, right? So, well, there it is, 3.0959, right? No worry about that one. Okay? So that's how you can make it log base 3. So let's go back and see, I think the other one's log base 2, right? Well, let's see if we can do that one. First, let's make an educated guess. Let's find out what it must be between. Has somebody figured out what it must be between already? Or no? Well, again, if you don't know, you can just kind of start. Well, 2 to the first is 2, right? So that's probably more than 1, right? 2 to the second, 4. 2 to the third, 8. 2 to the fourth, 16. 2 to the fifth, 32. So I have found a place where this kind of fits, because what question is this really asking? It's asking 2 to what power will give me 25. That's really what it's saying. And so I would say this one fits in right there. So between 4 and 5 somewhere. This one's kind of right in the middle, isn't it? So let's see if you can adjust your guesses based on how you know exponentials work now. They start slow and then take off. Right? So make your educated guess and then go ahead and type it into your calculator if you haven't already done so. And then we'll see how close your guess was. So in this case, I've used common logarithm to basically write something that was log base 2, right? Kind of cheated a little bit. And hopefully this is what you got. So is it necessary to round? Yes, it is, because it keeps going. And now when we round to the nearest 10 thousandths, it's 4.643 what? Last number should be 9, right, if you round that up. Is that where your guess was? It should have been more than 4.5, really, because remember, it starts slow and then takes off. Especially with positives, that's easier. And numbers bigger than 1. Okay, so any questions on that? All right. I'm going to give you a little bit of time then. I'm going to challenge you with this problem right here. So first, write it down, this next problem. So it's example 4. And then I challenge you to come up with something. So please create a logarithm problem that we should be able to solve without using a calculator. Notice I highlighted solve, because I don't want to just be able to make an educated guess about it. I want to be able to solve it and know what it is. Okay? So making you think a little bit backwards again. Okay? We could probably make that a little bigger, though, huh? Although I've been struggling with that. Let's go ahead and take a minute or two and try that. All right, hopefully that's been enough time to kind of try and come up with some. If you're listening to the recording, please actually pause it there and actually create some instead of just cheating and writing down the ones we have here. All right, so who would like to begin our list of ones that they believe we can solve without the use of a calculator? Yes? Sure, if you want to come up and write it, that's fine. But don't write the answer. We'll have to see if everybody else can figure it out. All right. I saw a couple of good ones up here in the corner. All right, log, okay. Ooh, base 4 of 16. Is that one we should be able to solve? Yeah, what's the answer? 2, very good. Okay. There's some students that might not be able to solve that one. Okay. Yep, go ahead. Might be next. Well, your hand was up, right? Okay. Yeah, if you can be after that gentleman back there in the green sweatshirt. Don't want to name names because it's recording, you know. Oh, I think somebody took yours. Sorry. Something similar, right? Well, does it matter what the base says? You could have put anything in the base, right? I think he kind of stole quite a few people's, though. But that shows that you understand these, though. What's the answer? 0, right? Yeah, when it's a 1 here, who cares what you put down there in the base? It's that to what power gives you 1, it's 0. Okay, does anybody have one other than 0 answer that they would like to share? Yeah. Would you like me to write it, or Okay, I got it. Okay. Yeah, now some people might know who that was, though. Ooh, log 3 of 3. Is that one we can do without a calculator? Yeah, definitely. What is it? 1. Very good. Okay, a few things I've noticed. All of you chose this type of problem. I just said a logarithm problem. I didn't say it had to be like this. And you all chose black. I don't know. Because you could have done something just as simple, right? That's a logarithm problem. Can be easily solved without a calculator, correct? But all of you went with what you saw today, right? But that's fine. Either way works, right? Because the answer to that one over there that I just wrote in blue is 7, right? Yeah, not 4, no, 7. Okay. Anybody else want to share one? Okay. So very good. It seems as though you are starting to have a good understanding of the logarithms and how they work and what they're trying to solve. And that's good. Okay, because you're going to need that understanding when we do the next section. Okay. Excellent.